Hello everyone, welcome back to the channel. I came back with another interesting video on the Kubernetes. In this particular video, we are going to talk about what exactly happens behind the scene whenever we run a command kubectl apply and one YAML file. Okay, when we give the YAML file as an input, right? So in our earlier video, we have already discussed about what is deployment, what is the use of it. We have deployed that deployment. We have seen how exactly it is working and all, right? So that we have done already, right? But now what we are going to do is what exactly happens behind the scene, right? So we already talked about this cluster, right? And then we talked about if you want to deploy any application, what we do is we write some YAML and then from a kubectl command, we run that YAML, okay? So now when we run it, what exactly happens? That's what we're going to discuss in this video, right? So let me go back to the sequence diagram that I have, where I'll try to explain what exactly happens. See here, you can say this user, okay? This is the user who is going to run that command, okay? Like a kubectl apply -f, and you'll give some input as an YAML file, okay? Let's say in this example, we are going to talk about a deployment. So we'll, let's say, give a deployment YAML, okay? Because we are going to talk about what happens behind the scene in a deployment from beginning to end, right? So what we'll do is, first of all, either we'll write our own YAML, okay, or we can basically generate it from the template, right? And then we can run the kubectl command like kubectl apply -f, and we can do that deploy.yaml file as an input. So first thing that happens here is this kubectl will first of all validate if that file structure is proper, all the attributes that we have used, those are correct, those are used in the proper hierarchy, okay, their spelling is correct. All that validation happens first of all at the kubectl end only. Once that is valid, the request will be sent to the API server, which is running on the master node, right? Now, on the master node, whenever any request comes into the API server, first of all, first thing that it will do is an authentication. Okay. So now how it is going to authenticate that, okay, we got the request from a specific kubectl. So what happens is every kubectl, okay, will look for one configuration file which is there under home directory.kube folder, a config directory, okay? And that's what getting basically initialized, or that file will be created as soon as the cluster is created, right? So inside that config file, basically, you'll have all the certificates, and that certificate will help us API server to basically authenticate, okay, that user is correct or not. That's what the first step will happen, okay? If that is correct, that authentication will be successful. Next step that will happen is an authorization. Now, what is the need of authorization? You cannot just have any user a full access of your cluster. We cannot do that. We have to somewhere, we have to put a restriction on that, like, okay, this guy can do only this much operation on the cluster, okay? This is another guy who needs some more access, or need to give an access to them some specific namespace, right? So in a Kubernetes, we have a concept called as a role-based authentication control. So we can create some role and we can assign to those user, and whatever is defined in the role, only that task are allowed to for that user to do, right? So whether that user is really doing the assigned task only, or he is trying to do something else, that is what will be validated here. Okay, if he is doing what is allowed, authorization will be passed. If he is not doing what is allowed, or he is trying to do it something different, then the authorization will fail and will get the request, right? So let's consider now authorization is also successful. What next will happen? The admission control. Now, what is meant by admission control? So in a Kubernetes, we have a way to put a restriction on how much resources can be used by a specific namespace or a specific user, right? And that we can define with the help of resource quota. Okay, in a Kubernetes object, we have one object called as a resource quota. So with the help of that resource quota, we can have some restriction. And then once we have that restriction, whenever any user is trying to do something in any specific namespace, that admission control will validate whether it is doing within a specified limit, right? If it is doing, it will be successful. If it is not, it will fail and will get a kind of a forbidden kind of error. Okay, so let's consider now admission control is also successful. So in that case, that request will be stored into the etcd. Okay, etcd is our key value store, so it will store into the etcd. Okay, and as soon as that is done, there will be a callback which will basically publish the object. Okay, whatever object we are creating. So in this example, we are going to talk about the deployment. So deployment object will be published. As soon as the deployment object will be published, there will be a deployment controller. Okay, as part of the controller, there will be a deployment controller. Now, deployment controller will understand that, okay, now this is a deployment object. So for this deployment, I have to create the replica set. So it will publish the replica set object. Okay, so you can see this is a controller part, and then we are informing the API server that, okay, publish the replica set. Okay, as soon as the replica set is published, then associated replica set controller will be alerted, and which is responsible for basically publish those number of pods. Okay, whatever we have defined in our deploy.yaml. If you have given the replica as 2, so 2 pods will be published. If you have given 1 pod will be published. If you have given 20 pods will be published, right? So this is what we do in the first step. Okay, so now as per the number of replicas, those many pods will be published. Okay, so API server will publish those many pods. Now what happens next is, let me go to the second part of it. So here, as soon as the pod publish, okay, now even if you have 10 pod published, for each pod, this is the same. Okay, whatever the process that we are going to talk about, that will happen same for all the pods, right? So as soon as the pod is published, scheduler will get a notification that, okay, there is a new request or there is a new pod that we need to schedule, right? So scheduler has some different scheduling algorithms or filters. It will apply those. Okay, and it will find the best node. Let's say we have node 1, node 2, node 3. So scheduler will, let's say, on the basis of its algorithm, he found that, okay, for this particular pod, a node 1 is the best node. So it will do the binding with that node 1. Okay, and it will send that binding details to the API server. Okay, and now we know that as soon as we create a Kubernetes cluster, the kubelet running on each node is continuously in talk with the API server, right? So API server will send that request. Now let's say API server got the details from the scheduler that this pod can be scheduled on the node 1. So API server will send that request to the kubelet of node 1. Okay, so then now kubelet will create a environment required for that particular pod. Okay, and then it will work with a container runtime engine, that is Docker, and our CNI plugin, that is our maybe whatever we are using, Calico, ViewNet, KindNet, whatever the plugin we are using. It will create all the networking related stuff like creating a virtual interfaces, creating the IPs, right? Then the kubelet will pull that image. The Docker will create a container for that, right? Once that is done, kubelet will run some liveness readiness probe. Okay, I'll create a separate video about liveness and readiness probe, what it is. And then once all this is done, then finally we'll get a pod status as a ready. Okay, whenever we do the kubectl get pod, we'll be able to see that pod status as a ready. And this same process will happen for each pod, right? Like for each pod, scheduler will find the best node. Then API server will send that request to the kubelet of that node. Then kubelet will work with the CNI plugin and the Docker and will create the proper environment, pull the image and create a container, and then start the container, and we'll see that status on the API server side that, okay, pod is successfully run, right? So this is what happens as soon as we run any command that, okay, kubectl apply. Okay, from this kubectl, when we have this, let's say this YAML created, so kubectl will just hit the command, and as soon as we hit the command, whatever we discussed just now, that is what's going to happen behind the scene. So especially in the interviews, you will get this kind of a question, and they will ask you about, like, okay, when you run any YAML file on the kubectl, what is the procedure or what is the workflow happens behind the scene? So that's what you should know, right? So that's what we discussed. I hope everyone understood about this flow. I will attach that diagrams and the workflow on the in the this video description. So please go through it. If you have any question, please put a comment. If you like the video, please share it with your friends. And if you are not subscribed yet, please subscribe the channel. Thanks everyone. See you in next video.